Get started, right? Okay. So in the last class, we talked about producer equilibrium, right? Now, let me give you a quick recap of what we have done before this. So this is unit 2. Before this, we have talked about consumer equilibrium, where we discussed that how consumers maximize their total utility, right? What is utility? Utility is the satisfaction that consumers get from their consumption. And we looked at this graph, this model, where we discussed how do consumers maximize their utility. In that model, we looked at two graphs, right? So we looked at budget line, and we looked at budget line, and we looked at indifference curves, right? So where indifference curve, like shown over here, where indifference curve is tangent to your budget line, that is basically where your indifference curve is tangent to your budget line, like this, that is your equilibrium point, right? Okay, so you have good x on the x-axis, you have good y on the y-axis, and where the two curves are tangent to each other, that is the equilibrium point, right? So we have already discussed this, right? So that was consumer equilibrium, that shows what quantities of the two products a consumer would consume to maximize his total utility. Now, after that model, we started off with producer equilibrium in the last class, right? Now, what is producer equilibrium? Producer equilibrium is a model very similar to consumer equilibrium. Here we'll look at how producers decide which resources to use, right? Now think about this. Oftentimes, resources are substitutable with each other, right? Oftentimes, resources substitutable, which means that either you can produce something using more capital or you can produce something using more labor. So in that case, how will a producer decide which resources to use? That is what producer equilibrium will help us to determine. Okay. So let's read this and then move forward. What is producer equilibrium? Producer equilibrium is a model that predicts how producers will allocate the investment between different resources. Between different resources, what we mean here is different resources slash inputs, right? Okay, now this being said, what should a producer consider to decide which resources to use, right? So I asked you this question, if you remember, I asked you this question, that what aspects a producer should consider to decide whether to use more capital or whether to use more labor. Now, if you remember, as an answer to this question, we agreed that there are two things that are important for a producer to consider to decide which resource to use. Now, think about this. What is the utility of a resource? On one hand, the resource is producing the output for you, and on the other hand, there is some cost that you have to pay to produce that output. Students, are you following me? So what is the benefit of using a resource? So what is a resource? Resource is any input that you need to produce an output, right? So how much output will that resource provide? Like if you're using labor, how many units of output will that labor produce? Similarly, if you're using a capital machine, right, a machinery, right, how much output will that machinery produce? That is the output that you need to consider, and compare that with the cost that you have to pay to produce uh, that output, right, which we'll see in a bit. Okay, now this being said, what is the objective of the producer? Now, the objective of a producer is to maximize the output with available amount of investment, right? So with available amount of investment, the producers would want to produce as much output as much they can, right? That's the producer objective, right? To construct producer equilibrium, what do you need? You need two graphs. To construct producer equilibrium, you need two graphs, namely isocost and isocon, right? So let's look at this through the graph, because that will help you better understand. Okay, now students, think about this. First thing that you need to do, right, you have to make a normal graph, right, like this. Then you have to name the axes, right? You have to name the axes. So on the y-axis, let's say you are taking the quantity of labor, and on the x-axis you are taking the quantity of labor, right? So it would look like this. So you would have, let's say, capital on the y-axis, units of capital, right? How many units of machinery or how many units of, tools. Basically, capital, is machinery, man-made resources. And on the x-axis over here, you will have the quantity of labor that a firm is willing to employ. So you have units of labor on the x-axis and you have quantity of capital on the y-axis. Okay. Now, first thing that we're about to make on this graph is the ISO cost, right? On this diagram, the first graph that we're about to make is the ISO cost. Now, what is ISO cost, right? I will show you the definition in a bit, right? So ISO cost is the graph that shows how many units of two inputs are affordable by a producer with available amount of investment. I repeat, so ISO cost is a graph that shows producers affordability in terms of two resources, capital and labor, right? Okay, now let's assume that the total investment that is available, to this uh, producer is $1,000, right? So $1,000 is the total investment available, and the price of each unit of labor is, let's say, each person is paid, let's say, $10 per day, right? And each unit of capital is paid. And if you remember, I said that capital is normally denoted with K, right? So don't get confused, even though we write capital in English language, it comes with the C, but the notation that we use for capital over here will be K, right? So let's say the price of each unit of capital is $20, right? Now, first thing that you have to make on this graph is the ISO cost, right? Now, first thing that you have to determine is what is the maximum quantity of labor that you can afford with available amount of investment and this much price of labor for each unit, right? So if you spend all of your resources on buying labor, how many units of labor can you hire? So that would be 1,000 divided by 10, as simple, right? So each labor unit is for $10, so that gives you a maximum of 100 units. So you can hire 100 units of labor, right? Am I making sense? So on this point, if I label this point as A, on this point, it shows that the company is spending all of its investment on hiring labor and no investment on hiring capital. That's the first thing that you need to remember. Then, on the other hand, if the company spends all of its investment on hiring capital, right? On hiring capital, right? So then that would be 1,000 divided by 20 because each unit of capital is for $20, as you can see, right? So that would give you a maximum of how many? 50 units. So maximum quantity that you can hire of capital if you spend all of your investment on hiring capital would be 50 units. Now you connect these two dots and you will be able to get the ISO cost for the firm, right? 50 capital units, right, exactly. So think about this. So you connect simply these two dots, right? A and B, that is your ISO cost, right? Is it simple? Okay, now what is this ISO cost showing us? Just like the concept of budget line that used to show, that showed that any point within the curve and any point on the line is affordable. Any point within the curve and any point on the line. So you can choose any random points on the line or within the curve. All of these points are affordable, right? But any point outside the curve is not affordable. Another thing that's important for you to know is that if there's a point outside the curve, that is straight away, we know that it's not affordable, right? So D is not affordable, right? Okay, but what about the point E? What about the point, let's say, what about this point G compared to this point E? Now, since point E is on the line, since point E, this point I'm talking about, it's on the line, this means that it will completely exhaust the investment of the producer. Do you remember? It's very similar to what we did in the budget line, in the consumer equilibrium, because any point on the budget line meant that the consumer is spending all of his income and he or she is not saving anything for the later use. I'm right with that, right? But any point within the budget line used to show that you're saving something for the later. So same is the concept in this graph, ISO cost, which we call. So any point within the ISO cost means that you're not fully spending your investment, and any point on the line means that you're fully spending your investment, right? You're not saving anything, right? Easy. We good. Can move on. Okay. Now this was your ISO cost. Now, second thing that you need on the graph, right? So let me show you over it, is the ISO-cont. Do let me know if there is anything that is confusing, right? Even though we did do this in the previous class, but if there is anything that you find confusing, please ask me there and then. Okay, now the second graph that we're about to make is the isocont. What is that called? Isocont. And what is isocont? Isocont is a graph that shows combination of capital and labor that yield the same level of output. I repeat again, right? So isocont is a graph that shows combination of labor and capital that yield the same level of total output. Let me show you over here, right? So on the y-axis, as I've shown, you have units of capital. On the x-axis, you have units of labor. Okay. Now, isocont would look like this. And what would a certain isocont show you? It will show you the quantities like this, right? A downward sloping graph like this. It will show you the quantities of, it will show you what combination of capital and labor can you use to produce a certain output, a certain level of output, right? Just give me a second. Yes. Okay, have a look at this. It will be something like this. Okay, similarly, another isocont would be higher than this, and so on and so forth, right? So this is one isocont in the pink line, then you have another isocont with the orange line, then you have another isocont with the green line, and so on and so forth. Okay, now what is this isocont showing you? It's just like the shape of indifference curve, if you remember, right? Now, each isocont will show you a certain quantity of output that can be produced. So let's say this isocont is showing you 100 units of output that can be produced. This orange isocont is showing you 200 units of output that you can produce, and this green isocont is showing you 300 units of output that you can produce. Okay, now if I choose random points, on A, B, and C, right? What would this show? This shows that on A, you're using this many quantities of A. Students, are you following me or not? You're using this much quantities of A, let's say 10 quantities of A, 10 quantities of capital, and 5 quantities of labor, right? 5 quantities of labor. And on B, you're using this many, quantities of, sorry about that, right? On B, you were using this many quantities of, right? Just give me a second. Let me make it first 5, and let's say 10. And in the case of A, it was, let's say, it was 10 and it was 6, right? And in the case of C, it was, let's say, 2 quantities of capital and 12 quantities of labor, right? Easy. Okay, now students, have a look at this. Even though on point A, B, and C, you are using different combinations of the inputs, yes or no? Even though on point A, B, and C, you are using different combination of the inputs. In A, you're using more capital and less labor. On B, you're using slightly more labor and less capital. And in C, you're using even much more labor and much less capital. But since all the 3 points are on the same isocont, that means that it will produce the same level of output. What does this mean? This means that this isocont, right? This isocont will produce the same level of output. Is making sense, right? So students, that's what you need to remember. Okay, now if you have to produce 200 units of output, what do you need? So if you need 200 units of output, don't you think that you will need more resources, students? If you need to produce 200 units of output, do you think you will need more inputs? Yes, you will need more inputs, and that's the reason why if I choose any point on this orange isocont, orange isocont, then you can see it for yourself that point D will be requiring more units of both the inputs. It will require more units of both the inputs. Students, are you following me? So in this case, as you can see, that you require more units of both the inputs, right? Because it is on a higher ISO quant, which means that you are producing more units of output. How many of you are clear on this? Right? So coming back to the definition so that we get a better idea of what isoquant and isocost shows. Isocost is a graph. Can you see my screen, students? Isocost is a graph that shows the quantities of two resources, usually labor and capital, right? So write this down. That a producer can afford with available amount of investment. That's what we looked at. And what is isoquant? Isoquant is a graph that shows the level of output a producer can produce using different combinations of labor and capital. Shows the level of output. What is isoquant? A graph that shows certain level of output. Certain level of output will be better. Shows level of output that a producer can produce level of output, just a second, that a producer can produce using different combinations of labor and capital. Right? Is this making sense? Huda and Preet, anything that's confusing, anything that you did not understand how was it, right? So isocost shows the affordability of the two resources, labor and capital, and isoquant shows the combination of the two resources that a producer needs to produce a certain level of output. Now, moving forward from here, where the two will be tangent to each other. Think about this. This was the isocost of this producer with this much amount of investment, and we assume that this much is the price of each unit of labor, and we assume this much is the price of each unit of capital. Now, this being said, what you will do is that you will draw, sorry about that, different isoquant. You will draw different isoquant on this graph, and there would be one isoquant that would be, and there would be one isoquant that will be tangent to your isocost. Is making sense, students? Let me draw a neater one, right? And do remember, just like indifference curve that are tangent to each other, isoquant are also tangent to each other. Parallel to each other. All the isoquants will be parallel to each other, so they can never intersect. Are you following me, right? So these downward sloping lines, you have to draw it like this, that they never cut each other. In fact, they are parallel to each other. It's always a challenge to draw the right one, but I mean on a graph, as long as exam, as long as you have made a slightly version, that should be good, right? So let's say this works for now. Okay, then you have another one that is further up, right? Again, it will be parallel to the other ones and so on, right? And then you can make perhaps one more to just show. Okay, now these are all the different isoquants that are made on the graph, right? So let's say this shows you that you can make, this shows that you can make 100 units of output. This shows that you can make 200 units of output, right? This shows that you can make 300 units of output, and this shows that you can make 400 units of output. Any confusion so far, right? Okay. Now, out of all these isoquants, which isoquant are affordable by the producer? Which isoquant are affordable by the producer with available amount of investment? Obviously, with available amount of investment, which isoquants are affordable by the producer? Can you tell me? Students, quickly. This should be simple. This was exactly the same concept that we discussed in our in the consumer equilibrium model. Yeah. Yeah. Come on. Just give me a second. Yeah. So my question was that out of all these 1, 2, 3, 4, out of these 4 isoquants, which isoquants are affordable, or which level of output is affordable by the business given the available amount of investment? Yeah. only 100 and 200. Why? Because 100 and 200, 100 and 200 level of graphs are lying within the isocost, right? So the 100 and 200 level of output is lying within the affordability. How do we know? Because either the graph, the blue graph is within the line of isocost, and the 200 isocont is tangent to your isocost, right? So these two are affordable. Anything that lies outside the budget line, it's kind of a budget line, right? So not exactly the name that we use over here, but what is isocost? Isocost is a budget line that shows producers affordability in terms of two resources. So these two which are way outside your isocost, obviously these are not affordable. Is it making sense? Right? Is it simple? Huda, did you get this part? Okay. Now out of these two, obviously we know that producer would want to operate on isocont 200 level. The producer will want to operate on the isocont 200. Why? Because that is a higher level of output compared to the 100 one. That is higher level of output compared to the 100 one, right? Now, at this point, what it shows us is that how much quantity of the two goods you would want to, how much quantity of the two resources you would want to have. So let's say this was the maximum of 50 units that you could have afforded for capital, and the maximum quantity of capital that you could have afforded was 50 and the maximum quantity was 100. So you're, let's say, hiring 30 units of capital and let's say I don't know, 60 units of labor to produce this output. Is this making sense? Is this clear? So this will be the equilibrium point where your isocont and isocost are tangent to each other, right? Where the isocost and isocont are tangent to each other, that is the equilibrium point in producer equilibrium diagram. Is it making sense? Okay, now we'll move forward from here. Now this is where it becomes this is where it becomes interesting and a little complicated. Okay, now think about this. If the two lines are tangent to each other, what does this mean? Right? It means that their gradient, right, will be equal to each other. Am I making sense? If two lines are tangent to each other, that means, right, that their gradient is equal. Okay, let me write it down over here, right? If two lines are tangent to each other, are you following me? For gradient lines equal to each other. Got this. Okay. Now, the next thing that we are about to look at. So the gradient has to be equal. This is something that is mathematically true. Let me also add this line. Something that is mathematically true. Now, this being said, what is the gradient of isocost? Let's first talk about gradient of isocost. So gradient of a normal downward sloping line like the isocost, it will be the price of the resource on the x-axis. We are talking about the gradient of the isocost first, right? So the gradient of the isocost will be the price of the resource on the x-axis, which in this case is what? Which in this case is PL, price of labor divided by price of capital, right? So that would be divided by price of capital. Did you guys get this, right? So price of labor divided by price of capital will be your gradient, of isocost. Any confusion so far? Right. Great. And now this is making sense, right? And again, as I said, since this is not a maths class, so you do not need to worry about that. How do we prove it? They will not ask you why the gradient is this. All you have to remember that this is what the gradient of isocost is, and it comes with a negative sign. What does it comes with? It comes with a negative sign. Okay, perfect, right? So let's go back and let's write this down on a note. So gradient of isocost comes with negative PL, right? PL divided by price of capital. Is it making sense? Why is this negative? Because it's a downward sloping line, so obviously the gradient will always be negative. Now the second thing that we're about to discuss is the gradient of isocont. Now this is what you have to pay close attention to. So let me write that down first and then I'll explain you what that means. So MPL means marginal product of labor divided by marginal labor of capital. Now this is something that you might be hearing for the first time, right? So we have not talked about what the marginal product of labor is and what the marginal product of capital is. So let me write this down. Marginal product of labor divided by capital. Now think about this, students. Okay, what is marginal? So let's talk about each one of these one by one. Uh, you do know what marginal means in economics, right? So you know marginal means additional. Now, if I say that there is marginal product of labor, before this in the consumer equilibrium model, we talked about the term marginal utility. So marginal utility used to be additional utility extracted from consumption of one more unit of the good. So additional utility that a consumer extracts from consuming one more unit of the good is known as marginal utility. Now here we're talking about marginal product of labor. Now marginal means additional and product means output. Product means output. So we will be using this term very frequently later on in the syllabus as well. So do remember at this stage that marginal, you already know it's additional, and product means product means output. Is it making sense, students? Okay, now think about it. So marginal product of labor refers to output produced by each additional unit of labor. Is it making sense? So what is marginal product of labor? So marginal product of labor means additional output, whatever that could be footballs, that could be laptops, that could be cell phones, that could be anything, right? Because the producer obviously can produce anything. So marginal product of labor refers to additional output produced by each additional unit of labor hired. To give you an example of how we calculate that, right? So let's look at an example of how we calculate the marginal product of labor. So on the left column you have the output, and or let's do it like this, right? So on the left column, let's take, and on the right column we'll take, is it making sense? Okay, now you hire the first, you hire the second, you hire the third unit of labor, you hire the fourth unit of labor, then you hire the fifth unit of labor and the sixth unit of labor. Okay, now let me tell you, let's take an example. Let's take an example of what this company is about, because then you will better able to imagine and visualize. Okay, now students, think about this. Let's take an example of a football manufacturing company. So there's a football manufacturing company and the purpose is obviously to manufacture footballs, right? Now that being said, you have a certain quantity of capital, right? You have certain machines, so sometimes you might need the machine to, to make sure that the shape of the football is like a sphere, it's completely round, and it's not imperfect shape, and so on and so forth, right? So obviously there will be some machines and tools that you're using. Did you get my part? So there will be some tools, even if the labor is making the footballs, but there will be some tools like to cut thread, you will need some pair of scissors, or you will need to do other things, or let's say you are inflating the football with the air, and then you have to use a machine for that, blah blah blah. Obviously, no matter what type of manufacturing we imagine about, there is always some use of machines and capital that we make, right? Is this clear so far? Okay, now when you hire the first guy, let's say when you hire the first guy, right, he produces, let's say, 30 footballs on his own, right? So the total output for the company when you hired the first guy was 30 footballs. Then when you hired the second guy, the total output increased from 30 to 45. When you hired the third guy, the total output of the company increased from, let's say, 45 to 55. When you hired the fourth guy, the total output increased from 55 to, let's say, 60. When you hired this fifth guy, right? When you hired the fifth guy, the total output, let's say, increased from 60 to 63. Okay, now let's get rid of the sixth one. How many of you are clear on the values that I've shown over here? Huda and Preet, are you guys clear on what these values show? So let me also specify that this is total output that's being produced, right? In case you have any confusion. So this is the total output that we are looking at. Okay. Now let's look at what that actually means. First guy, total output of the company was 30 units of football. You had the second guy, the total output of the company was 45 units. For the third guy, after the third guy, the total output of the company was 55. After the fourth guy, it was 60. And after the fifth guy, it was 63. Now, what can you observe out of these values? Can you observe something? Can you observe something? What is happening? Is total output increasing? First question. Is total output as more? First question, right? First question. Total output is increasing. Okay. The average output is decreasing. That's correct. That's correct. Very smart. Right. Another thing. With each additional, so that is what, Preet, you're trying to say. With each additional unit of each additional unit of labor, or let's simply say each additional labor contributes less output to, right? Okay, now think about this, right? So the answer to the first question, we said yes. Is the total output of the firm increasing as more units of labor are hired? The answer to that was yes, right? Now, what I was telling you right now, if we have to calculate the marginal product in this case, so marginal product is the additional products, right? So think about this. When you hired the first guy, your output increased from 0 to 30. Now listen to this very carefully, students, otherwise you might feel confused about it. So when you hired the first guy, your output increased. Obviously, when there was zero labor, there was zero output. That's just how it happens, right? So when there's no person to manufacture anything, how would there be any output? So when you hired the first guy, your output increased from 0 to 30. So that means the first guy on his own contributed how much to output? The first guy on his own contributed 30 units to output. When you hired the second guy, right, the total output was 45, which technically means that the second person on his own produced how much? How do we calculate the marginal product? We subtract the total product at the level of 2 units of labor from the total output at the level of 1 unit of labor. Students, are you following? So that means the second guy on his own produced 15 units, and the third unit of labor on his own produced 10 units of labor, and then the fourth guy produced only the 5 units of football on his own, and then the last unit, or the fifth unit of labor, only produced 3 units of output. Is this making sense? How many of you are clear with this, students? Is it making sense? Right? Right? So marginal product, as you can see, is diminishing. Each additional labor contributes less output compared to the previous unit. This is known as law, and I'll also give you a reason why that happens. Law of diminishing marginal product. Law of diminishing marginal product of labor. What is this known? This is known as law of diminishing marginal product of labor, right? Okay. Is this simple? Okay. Now we just observe that as you hire, as a company, when you hire more units of any resource, normally normally it will be labor. Students, let me tell you, because out of all the four resources, land, labor, capital, and enterprise, which of out of these four resources, which resource do you think is easiest to increase? Out of the four resources, the name of which I've taken, land, labor, capital, and enterprise, which of out of these four, which of these is the easiest to increase? Right now, let's try to understand in a real life example. So if you think of a football manufacturing company, if you have to buy land, right, land like the physical land, or even if some natural resource, it will take some time because you will acquire a piece of land to construct a new building. You have to look for the suitable place and the suitable location. Why? Because obviously it has to be close to the supply of raw material, or the factory has to be close to the supply of market, close to the market where you will sell that output, and so on. So there are a couple of things that are involved in the decision making. Similarly, if you have to hire more machinery, more capital, right, then in that case, you will also look for the ideal machine. You will see where you can get it from the cheapest, whether you should import from China or should you import it from India or any other country, right? Okay, so that's also some time consuming process. Now, enterprise is normally fixed, right? Whatever the management is, I mean, that keeps increasing, but I mean, enterprise, let's assume that it's constant at the moment. The same person who is running one factory would be good enough to run another factory. But out of all the options that I've discussed, labor would perhaps be the easiest one to increase. Why? Because you just need to, I mean, it's not very skillful job, right? So you just need to advertise in the newspaper or whatever the platforms are, and then you will receive a couple of applications. You hire some people who are good fit, and you give them some basic level of training, and I think they will be in good enough position to start manufacturing. Is it making sense? Now, as you increase the quantities, this is variable input, right? So we are not going in that detail at the moment, but there will be variable inputs and then there are fixed inputs. So variable input is any resource that can be easily increased and decreased in the business, and then you have fixed inputs. Fixed inputs. So as I just explained, fixed inputs are relatively difficult to increase or even decrease in certain point in time, right? Is it making sense? So during a certain point in time, it will be difficult to increase or decrease, or simply speaking, adjust. It will be difficult. For fixed inputs, it's difficult for the business to adjust the quantities of that resource, whereas for the variable inputs, it's easier for the business, right, to increase or decrease their quantities, like labor to increase or decrease in quantity. Did you get this? Okay. So Huda and Preet, did you guys get this, right? So there are variable inputs and then there are fixed inputs. So variable inputs, as I said, so these are the resources like labor. These are relatively easier to adjust. The quantities of these resources relatively easier to adjust by the business, right? And whereas for the fixed, it's relatively difficult, right? Okay, let me send you a new link and we'll try to wrap this class up, and then we'll continue from in the, I'm sending in the new link.